All right. Thank you, everybody, for attending today, the OpenFMB webinar on advancing EV integration and interoperability certification for the grid edge. Next slide, please, Stuart. I'm just going to take a second to talk about general housekeeping. This webinar is being recorded. If you don't wish to be recorded or have your questions recorded, please leave the meeting now. At the end of this meeting, a recording will be automatically sent to all registered attendees, so don't worry about that. And we'll post it on the UCA and OpenFMB websites under the past meeting sections. All attendees are muted by default, so please keep your questions and comments to the meeting chat. At the end of the meeting or towards the end, there'll be a Q&A section. At this time, please submit your questions to the Q&A option at the top of your screen. If that doesn't exist, feel free to use this chat window, but only during the Q&A section. Next slide, please. We have an antitrust policy. We're not biased in anything we talk about. All participants in the activities should be aware of this, and we will enforce such policies during the participation in this activity. This pertains to current or future prices, any price-related information, output capacities, any market share, current or future marketing strategies. If you become aware of a violation of the antitrust policies, you can bring that to the attention of the meeting chair or to the UCA chair or UCA president, Ryan Wilcoxon. Next slide, please. Today from OpenFMB Users Group, we are going to hear from Stuart Laval, Michael Burke, Jed Bartlett, Alex Surov, and Kurt Kirkaby. Next slide, please. For today's agenda, we started out with the opening and introduction. We'll do a welcome and a meeting overview, some UCA announcements, an OpenFMB overview, the current state of the user group, future activities, and lastly, the Q&A and next steps. Next slide, please. All right, Stuart, I'm going to hand it over to you for the overview.
All right. Good day, everyone. My name is Stuart Laval. I work for Eaton. Been with Eaton for about 4 years now. Prior to Eaton, I actually was in the utility industry. I worked at Duke Energy for about 8.5 years. And I've been actively involved with the OpenFMB or Open Field Message Bus Users Group from the inception. That started in 2015 as a smart grid interoperability plan, priority action plan. Then it became a North America Energy Standards Board standard. And then since then has been used in a number of utility pilot projects to address some of these mega trends that I'm showing on the screen. If I start from the left, move to the right, we move to more complex problems that we're running into. Initially, the genesis of OpenFMB was really to solve decarbonization or around distributed energy resource interconnection. A lot of these inverter-based resources have low inertia, power electronics based. The controls are much faster than the traditional rotating mass generation. And so having edge intelligence close to the distributed energy resource was one of the reasons for needing interoperability at the edge. Other trends that have been pervasive over the last decade or so is around extreme weather events. And not only are utilities adding more intelligence to restore the grid faster, to improve their indices around either reducing permanent faults and SAIDI, as well as trying to reduce the momentary faults and improve their MAFI as well. In addition to outage restoration, there's been a lot of disasters around wildfires, especially on the West Coast in the past several years. And there's been a need for improved situational awareness and intelligence at the edge to proactively determine where there could be high impedance fault events. Additionally, we have electrification megatrends around not only electric vehicle fleet, but more recently, artificial intelligence has been driving the data centers to increase their loads significantly. The racks traditionally in the kilowatts are now moving to the megawatts. And as you start to multiply them to power some of these newer AI data centers in the future, this could be hundreds of megawatts, if not gigawatts of power required. And it's going to require a combination of bulk power as well as on-site microgrid generation. And the last trend, which is still evolving, is around this prosumer market driven by FERC Order 2222, which allows the essentially transactive energy being able to have customers behind the meter working with aggregators to play in the market, wholesale markets. So all these trends are what's driving the need for distributed intelligence. If we just do a brief comparison between today's grid and tomorrow's grid, you can see there's vast changes that relates to the penetration of DERs going from less than 10% to potentially over 50%. Both load and customer behavior is changing, making it hard to predict the patterns and demographics. Asset visibility is more than just an as-built model in planning tools that we want to pull from your geospatial information systems. It's now becoming the need for real-time as-operated models with a lot more fidelity in your grid connectivity model in real time. From a controls perspective, for the past decade or two, more than multiple decades, controls have been acceptable with centralized management. Unidirectional power flow, command and control. Moving forward, not only do we need to continue these centralized systems, we need to augment them in a way that can handle some of these local decisions for both utility and customer and assets in a much faster response time. In terms of compute and analytics, today, most of them are done, whether it's through AMI or DMS, in minutes. Some of these decisions will need to be done sub-second as we talk about inverters that are power electronics based. A lot of these decisions are, in some cases, cycles. And then from an IT and a cybersecurity perspective, we need to move away from proprietary systems where we have a lack of visibility to more open, interoperable plug-and-play systems that in the future hopefully will adapt frameworks like zero trust security to improve the security posture of the system as we're communicating more on the grid. And just kind of the main takeaway from this slide is distributed intelligence, or DI, is a transformational solution that can help mitigate and satisfy the future customer operational needs of the grid. This slide here kind of defines distributed intelligence. We leverage the Department of Energy's definition. A lot of the work was done by Jeffrey Taft for his grid architecture framework. And DI, based on that framework, is a multi-layered federated architecture. It supports coordination between multiple devices and systems to solve a common problem or use case. But it needs to do this in a way that augments both traditional centralized models with the new autonomous controls at the edge. If you look in the picture on the left, this is the current state of a lot of these centralized systems with advanced distribution management systems or SCADA systems that are essentially hub and spoke communications, a north-south interaction pattern from device up to the back office. And then for some of the DERs that are customer owned, that are behind the meter, those would communicate north-south as well up to an aggregator. And then those aggregators would have to integrate with the utility. As we get to new use cases where we need much faster controls and potentially local decisions that could have east-west communications, that's where distributed intelligence comes into play. It not only can help solve problems locally, it can also coordinate with those central systems like an ADMS or DERMS. So that's really the goal, is to really augment and enhance this existing central model. So instead of only relying on minutes of latencies for decisions and controls, we can now offer some more local, microgrid or feeder level decisions that can happen in seconds. So for Primer for OpenFMB, it was really geared to help, augment the grid controls that are starting to become distributed, and also enable an architecture that's more federated. And it does this through two major building blocks. One is publish subscribe communications. So under the hood of an edge compute device, there's essentially the ability to convert legacy protocols such as DMP3 or Modbus into an interoperable format. And this is able to bridge and integrate directly with other systems that have these types of OpenFMB capable devices. And ultimately, what the benefits from this is that operational solutions would be able to improve their fidelity and granularity of data in a much faster way. I believe by having the ability to distribute should scale better in the long run and hopefully handle a lot of these OT-IT convergence issues. And the outcome would essentially be improving security, safety, resilience, and financial, because you have the ability now to run multiple use cases in parallel and stack operational benefits. So this slide really helps define what Open Field Message Bus is. It is a framework for grid edge interoperability, which ultimately can help support distributed intelligence. It was a standard ratified in 2020 by the North American Standards Board. It effectively leverages existing standards such as the IEC 62150 and the Common Information Model, data structures, as well as logical nodes, and puts it in a format that can be shared east, west, and north-south through using Internet of Things protocols that are interoperable, in the industry. The foundational use case was around microgrids and DERs, but we're now starting to see a lot more expansions as we start to see these mega trends like electrification, as well as some of the distribution automation use cases around outage restoration and wildfires. And one of the major components of this framework is to leverage what we call protocol adapters or converters that quickly can complement each asset, but either north or south, quickly translate to and from these legacy protocols. So if you look at the picture on the right, starting at the bottom, your traditional asset may have protocols that are points-based, like Modbus or DMP3 or 62150, or it may have some of these more schema-based protocols like the new ones today, like 23.5, OCPP, OpenADR. So how do we not only bridge these two different worlds, whether it's points or schema messages, and federate that data so that you can run applications at the edge in seconds, such as being able to process DER, use case around, load shaving, smoother smoothing. Some of these new 1547 functions might need to be converted at a much faster resolution. And then also coordinate with your SCADA system or ADMS system. And then also, is there a way to, interoperate with these behind-the-meter aggregators? So hopefully that gives you an idea what the pain point OpenFMB is trying to solve. And with that, we built the data model to help be comprehensive, to cater toward both north and southbound. So we started with the Common Information Model because it has a very strong utility back office definition, leveraging the as-built topology models and very strong class structures. And then we added a lot of the meat and potatoes in depth from 6150 around the logical nodes to really provide that comprehensive definition of substation grid protection assets. And they've also recently added DER and EV logical nodes as well. So we were able to take advantage of that. And then using OpenFMB, we can kind of take the best of both worlds to harmonize both centralized and decentralized architectures. So I've completed the primer of OpenFMB. Now I'm going to pass it to Jed, who will go through the current state of the OpenFMB community.
Hello. My name is Jedediah Bartlett, or my friends call me Jed. Work at Schweitzer Engineering Laboratories. I've been here for about 17 years. In my previous life and my early career at SCL, I spent a lot of time with microgrids. And since then, been spending a lot of times on the controls aspects with some of our automation products that go into operable systems doing a lot of those kind of bespoke systems that Stuart talked about, and wishing that we had something kind of like this to be able to click things together. So I'm going to go through here and talk about where things are at, where you can find things today if you go look directly on the website. There are a couple legacy. If you go search on for OpenFMB, you might find some of our old websites and stuff like that. The one that you want to find and click on is the openfmb.org link. We've gone through and done a pretty good facelift. The UCA has done a great job of putting together some web infrastructure for us that we were able to leverage, and so I think that's pretty well navigable. We tried to answer a lot of the initial questions like the learn, put some tutorial videos that were made a very long time ago, kind of introduction. You should see some of the screenshots we grabbed off of there from some of the very early work that was done. And it's got links to our private and the public, or the public repositories that you can get to. They are controlled, so they're, and we'll talk a little bit about that later, about how we're evolving to be able to support contribution a little bit more, but they are read-only to the world. That all went live last year, and we've been continuing to evolve that. Next slide. So one of the things that we did was we had some stuff in a GitLab system before. So again, if you find that that's old, you want to look at the new GitHub repository structure. It's kind of set up modeled on how we put everything together originally. If you look at the OpenFMB Users Group, the first thing you'll want to look at is the platform independent model. It's the UML, and we'll have a screenshot about that in a second. That'll give you the basic overview of here's all the different objects that are in the system. Here's where they exist. Here's what they're supposed to do. It's got the scenarios and the use cases for everything that we're doing in that system. So if you want to know the why about why a specific point is in there, you should be able to kind of track that back up through the use cases using the UML. What we do is we take that UML and we put it into different manifestations. So we translate that out of the kind of object world where we describe what those objects are and their needs for signals and their needs for sharing information, the ability to share information. And we turn that into a description that is an actual object description. And we do that in a couple of different ways. Protobuf being one of the most commonly used with a lot of the transport mechanisms that we're using underneath of OpenFMB. So I really kind of want to highlight here that OpenFMB is not a protocol the way that like Modbus is a protocol. OpenFMB is a protocol more like Sunspec is a protocol. It's an object first model, and it's trying to tie together a bunch of things, and it's made to be optimized instead of where a lot of the other systems are. It's made to really be optimized instead of a point-based system underneath of it, a pub subsystem underneath of it. And so the technologies and how you describe things to go into a pub subsystem looks quite a bit different. So it's not just an object model, it's an object model with an encoding, which is in that protobuf, which it becomes a platform-specific model. So we call it platform-specific because it is a particular manifestation of the concept of the UML. You'll see the UML lines up very well with other object models that you'll see out in the world, but the way that we've encoded it into the platform-specific model is optimized for those pub subsystems. We've got the adapter toolset that OES has put together. It's able to bring in things like DNP and bring them into OpenFMB, so you can have legacy translators between existing systems that exist out in the field. At some point in the future, maybe a lot more devices become OpenFMB native, but right now those are a pretty critical piece of the puzzle to be able to put OpenFMB into existing systems. And again, we kind of finished that at the middle of last year. Next slide. Our big 2.2 release was what we've been working on for most of the last year. The major focus for this was the inclusion and ability to work with EV charging stations. So we talked a lot about EV integration, how that's going to work, vehicle to grid, and the ability to plug a vehicle in. You don't plug a vehicle into the grid, you plug the vehicle into a charging station. That charging station has some capacity, which might be able to use the EV charging station. It might have some capacity internally within the charging station to have a battery locally to be able to handle peak loads and charge itself up when power is cheaper. And so there's a bunch of energy state there. We wanted to be able to make sure we were incorporating, as we've seen those show up in the grid more. We have a bit of an apology to David Lawrence. We don't have full DC grid capabilities to be able to balance a DC grid with an OpenFMB right now. That's still a thing that's evolving in the industry, but these EV systems do need to be able to advertise, and the operators of the system need to be able to have a little bit of transparency in terms of capabilities of what the state of charge is of these systems and what they're going to be capable of over a longer period of time. And so we've added these capability profiles into the system that's kind of unique to the EVSC space right now. But we kind of talked through how that can be adapted to other controllable loads that may have capacity inside of them. And again, that went live towards the end of last year. We do have the platform independent model and the platform specific model all ready to go, and all of the repositories in the GitHub project are all updated. Next slide. Yep. Speaking of GitHub, so I alluded to this a little bit earlier, but I want to walk through it just to make sure people kind of understand, because I think this is the biggest question we get when people come into OpenFMB the first time is, what are all the different repositories? Where am I supposed to start? So, like I said, start at the /PIM repository. That has inside of it an enterprise architect project. You can see the entire object model and get a good idea of where the space is laid out. So that's kind of your map for what you're going to be looking through. What we do with that platform independent model is we have some tooling that is able to take that UML and produce, in one case, the PDFs directly from it. So if you don't want to actually navigate around inside of Enterprise Architect and you want some flatter documentation, you can go over to the /use cases repository, and that's actually a publication. So you can kind of think of PIM as like the source code for everything. We have some manual compilation steps that we use to take that information, compile it into things like PDFs, and we put that in a separate repository that we keep aligned. So you'll see use cases with different versioned tags on there with all of the kind of flattened documentation that you can use in a little bit more consumable format. The other thing we do is we take the UML, we go through an XML transformation to describe all those objects from the UML. And then that gets translated into multiple different encoding mechanisms. And the primary one we're using now pretty much universally is protobuf. We had some other things in there originally, which is why we had the extra step of the XML in the first place. But those have largely been eschewed at this point in time, and we have just the PSM protobuf. So if you need to just take the object model and put it in any language that we don't support, you can go grab that protobuf. And it's pretty easy to take that and auto-generate all your structures and data integrations that you need into whatever programming language you want, so you can easily, at the application layer, pick up that data and use it. But because that's an extra step and it's pretty easy to do, we also have individual repositories where we've done that for you. So C++, Crystal, C#, Elixir, Golang, Java, Kotlin, Python, Ruby, Rust, and TypeScript all have pre-built bindings based on that protobuf. You can just pick up and import directly into your project to use in your application layer, and lets you publish and subscribe topics from the OpenFMB system. So that's most of your layout. Yep. Stuart's ahead of me here, doing great. When you go into the PIM model, you'll see there's a couple links on there, and there's a couple different ways to view the model. You can pull it up in Enterprise Architect, but the UCA has set it up so that we can actually directly view this in the online viewer right now. So now if you click on that latest version, you'll just pull this up and you can actually view it in browser now, which is really, really nice, because the Enterprise Architect installation was a big piece of friction for people. So We've got that exposed here right now. You can click through everything and again, see the circuit segment management, for example, and the primary scenarios of how we actually do that. I'll leave it as an exercise to the viewer. Please do, if even as we're talking, it might actually spawn some questions. If you guys want to go over to that, the URLs that are on the screen, openfmbUsersGroup.github.io/pim, and take a look through this, poke at it a little bit, see if you have any questions. We'll be happy to answer them at the end. All right. And hand this over to Alex now, who's going to tell us a little bit about the certification.
Yeah, hi everyone. I'm Alex Sarov. I'm the lead for the testing and eval group. Testing and eval group here at the Battery Innovation Center. And so we've been linked together with UCA and OpenFMB for quite a few years here, getting this test procedure and harness system set up at our facility. We're pursuing what is called ISO 17025, which if you're in the lab space, you'll probably know what that means. With this body, and trying to finalize that by the end of this kind of year-ish, so shooting for that Q3 or finalizing the actual steps for the certification and then offering late this year in that Q4. I hope this overall plot and graph makes sense with regards to what's happening. The bottom left is, again, a general overview of the pub sub idea, but on the right there, you can see the big here will be the laboratory where you can get your various devices certified to the OpenFMB standard. You want to go in the next slide? If you don't know much about who we are yet, here's a quick slide about who the Battery Innovation Center is. Essentially, we are a focused system of a nonprofit variety on anything and everything energy storage, right? So we do cell manufacturing, we do testing and validation, grid scale, application and understanding, DoD, DOE. I can list a whole giant another hour talking about this, but we have kind of three really main avenues here at the BIC. We do a lot of pilot scale cell manufacturing. So let's say you are convinced that a peanut butter and jelly battery is the best. We'll take your peanut butter, take your jelly, we'll put it together, we'll make it a battery, and we'll see what happens. That's not what my team is. I'm more on the testing and validation side. So we do everything from single cells to full packs into grid scale systems, right? And that's kind of where a lot of the interaction here comes from. We're involved in these grid scale concepts and these microgrid ideas, and so we're trying to support in OpenFMB and get this to have a real home, a real way to certify whatever we can to get this overall moving. And that's really all I had to say about the BIC, right? We're super excited to get the testing and certification finalized. We've been working hard with OpenFMB to make sure everything meets what we both want to see. And so we're excited to get this rolling by the end of the year. Go ahead, next slide. I'll go ahead and step away.
Thanks, Alex. I think Kurt, you're off mute.
Yep. Yeah. So we just released not too long ago the 2.2 OpenFMB version. There is a so basically OpenFMB, there's an adapter, right? It's an adapter concept that provides this ability to translate between different protocols. Currently supports DNP and Modbus, as well as from a network perspective, NATS and MQTT, which are two pub sub protocols. And you'll see in the repository and the website, there is an adapter configuration tool that allows you to set up your adapters. And basically, it's a very slick tool in that you can look through that in a multitude of ways, including you can just provide a spreadsheet into it, or you can graphically go through and pick each element that you want to assign either a Modbus point or a DNP point, and set up your adapter for a specific device. Of course, the key thing in the adapter, what's coming out is OpenFMB, so every device of the similar type is going to look the same from the standpoint of the data going back and forth. Your configuration sets it specific to the device in question. And so that tool is really nice. And you can see it there, the GitHub site has the documentation plus the instructions. There is a reference demo, and that reference demo I think is pretty slick and allows you to play a little bit with it and actually utilize some data. So it sets up a little grid for you and allows you to play and change those adapters as well as the HMI. So that I would encourage you to take a look at that and get some experience. Slide. So where do we go from here? We just released 2.2. And so for those of us who have been using OpenFMB, you start using it and then you find out that there are things that you might like to add to it. So this is a list of potential places that we might put effort in version 2.3. None of it is written in stone. None of it has been decided specifically as of yet. So these are just some thoughts from the folks that have been using. And the first is around extensibility. So we've got a good set of modules that represent devices. But what happens when you don't have that, and it's not an exact match, or you have lots of additional fields? For an example, an energy storage system might have a whole bunch of parameters that a utility is tracking that are not a part of a current SIM model, 61850 model, because they're utility specific. So how can you extend in a way that extendable object is easy to understand? And today we've been using resource profiles, but resource profiles don't really expose the naming convention of the item that you are trying, the field you're trying to represent. So don't really know exactly how we're going to do that, but we'd like that to be more done in a more standard way where it's discoverable, I guess might be the best term to use, so that we can easily qualify variables, enhance the portability, especially the readability. We really want to be able to understand through the normal tools what we're looking at in that OpenFMB pub/sub data set. And then the maintenance side of the things, it should be a lot easier if we're not having things wide open. So think about it as a text field where you put data in, but you can't do anything with it because you don't know what the text field parameters are. So we're trying to put more into the extensibility. Another side of things is since we are doing control at the edge, we also want applications to understand what is happening at the edge. And a key part of that is schedules. And so in the status profiles, we would like to be able to expose the control schedules that are set so that we can understand what is anticipated. So that's both an application and a device peer-to-peer awareness that we could really leverage today. And we don't really have that ability at the moment. You saw a little bit of the use case documentation there on circuit segment. So there are use cases included in the model. And I think it's one of maybe the harder things to understand exactly what that use case represents, or how you might, maybe a better way to say it is how you might implement that use case. So I think one of the things we would like to do is improve the documentation and maybe examples of those particular use cases, how they might be leveraged. And then in addition, we would like to extend or create new use cases around specific types of solutions like Flizzr, Volt bar optimization, microgrids. And then with the, of course, with the current trend of AI data center proliferation, how can we provide the flexibility in those use cases? What does that look like? It is different than a regular data center, given the training aspects of the AI data center. So there's some opportunity there and use cases that are different. And then EV fleet load shaping, that should be on the top of a lot of people's lists for managing large fleets of EV and having that use case be included in the OpenFMB model. And then finally, around, so we've got OpenFMB, we've got the messages being consistent, creating that interoperability layer peer-to-peer for devices, but what about applications? What about communication between those applications? Should we have something there around messaging? Should we have something? So it's a wide open area where we can explore how OpenFMB could provide that consistency, not just from devices, but it could provide it between applications. And so some thought needed there to understand exactly what we might do, but certainly a need that has been exposed. And then continue to extend the relevant data model profiles. So things such as price signals, because obviously there's going to be a lot more around optimizing DERs at the edge, and price is a key element. Next. So on a grander scheme, model-to-model transformations is an advantage that we have, right? With OpenFMB, currently we have 61850, we have DNP3. We kind of see it as the translator for all of these different standards, and if we're doing that, then we gain data consistency, right? And we understand the pathway to and from each one of these standards, because a standard, a portfolio of standards just creates another problem because those standards aren't necessarily interoperable. But can we bridge that gap with OpenFMB to make sure that the data definitions and typings are such that we can actually transform one to another? We've done a little bit of this with OpenADR, and it was it's not super simple to do. But if we go down this pathway, we can certainly enhance the model such that we can solve the challenges that we might currently have between transformations, and make sure that these specs are truly interoperable. So I think that we have an opportunity with this interoperability open source model to provide that bridge. Anybody who, well, I'll date myself now, but prior to ANSI standards on meters, there was a thing called MV90, and it did nothing but translate between different types of meter data. We kind of have that same problem today between specifications, and so we see it as possibly the way to bridge all of those models and transform one to another in an effective way. Next slide. So lastly, and Jed talked a little bit about it, that diagram on the left is how we execute the workflow today to get down to a protobuf that we pass back and forth on the network. And we're kind of caught in the moment, and we are in an enterprise architect modeling tool. And as Jed had alluded to, that may be prohibited at some client sites, utility sites, or it may just be cost prohibitive as well. So we believe there's some new pathways that will allow us to make it more human readable, and not so dependent upon a tool from a company, basically by putting it into a protobuf plus descriptions PIM model. And Jed, do you want to speak to any aspect of that specifically?
Yeah. I think we'd, this is kind of, we wanted to end here a little bit on involvement. So the OpenFMB standard has come a long way. And as Kurt was just talking about, being able to do those OpenFMB translations and protocol conversions quite easily. There's lots of stuff on our roadmap that we want to accomplish, and it's going to require quite a bit more involvement. And the people that we're interacting with and that need to be working with this system kind of work with it at a pretty low level. So I think we've got the high level object modeling and the 61850 constructs embedded pretty well at this point in time, which is why we were using the enterprise architect piece in the first place. That allowed us to make sure that we were sharing things back and forth and that everything was commensurate so we could move back and forth with 61850. What we're seeing now is that there's small details, from the actual applications need to be pushed back up. And so dealing with that high level top down model is a bit of friction at this point. And the people that we're working with like to work with, modern development workflow systems where you start with things that can be represented as plain flattened text. So you can do things like a diff and a contribution, and I can make a pull request to the system and say, here's some extra things that should be added. It satisfies these use cases. Everything can be described, looked at holistically, and a contribution can be made back into the system to enhance the next release. And those can be coordinated a little bit better. So that means elevating the protobuf to the authoritative source of truth instead of an intermediate, and then deriving those other things that we want from that space using tools that are, have evolved and become more commonplace than when we started this effort with OpenFMB, over 10 years ago, when the enterprise architect was the way to do things. Things have moved on. Being able to do those flattened workflows, we think, is important, and hopefully can invite other people into the space. So if you're the kind of person that wants to help out, or you want to be able to accommodate these workflows and have some people that are used to working in open source spaces and doing contributions, bringing those workflows into the system, and we'd invite anybody to come and help make this kind of pivot and transformation, along with all the other things that Kurt just talked about. It's going to take some work to get all these things done, and we're looking for industry partners to help us out with that. So hopefully this is one of the things we can do to make those things easier and lubricate that contribution.
Yes, I'll just say that, it is your participation that will allow us to move forward and enhance the model further in version 2.3. Mike's going to talk a little bit about that, so I will pass that on to Mike. Mike?
Yeah, thank you. I think that, so Mike Burke here, I'm with OES. I'm also a co-chair within the OpenFMB committee. So I'm happy that all of you guys are involved today and listening. So thank you very much for your attention. That really kind of concludes the time that we have, or the content that we have. But I wanted to make sure that we do have some time if you guys wanted to ask some questions. With the current setup that we have, everybody's still on mute. But if you click on the Q&A button at the very top of your screen, you can actually ask us questions. Apologies for the inefficiency there, but if you do want to ask some questions, we can possibly discuss them as a group right here, right now. I do want to say someone's already taken advantage of that. Dolly has written something about data centers, and I was curious, Kurt, if you had seen it. If you want to, I know you had commented a bit on data centers. If you wanted to potentially comment on that, or if someone else within the speaker group wanted to talk about it a bit.
Where do I see that question?
Q&A. We click the Q&A at top, and really anybody on the group could talk about it.
Oh, there
You
we
see
go.
it?
Okay. Yeah, I got it now. It's just coming up. Give me just a second. Hyperscale. So the question is, if hyperscale data centers are becoming de facto utilities, is the industry witnessing the early stages of a structural transition from centralized grids to a network of interconnected energy microsystems? For example, Google is acquiring energy assets. Example, Intersect Power. What does UCAIG plan to do? So I think, yes, the question is a good one, because that's exactly what's happening. Utilities do not have, in most cases, don't have enough transmission, don't have enough supply, and so the data centers are becoming their own utilities, and even price pressure, right? A lot of customers are not happy about the power suck coming from AI data centers, putting it squarely into a self-supplied type of a solution. So how do they play into the bigger grid is an important aspect, because they won't be disconnected. At least I don't believe they'll be disconnected. They will be interconnected, and they will be microgrids. So I think that that's exactly why we have OpenFMB, so that we can communicate both on a peer-to-peer, from a peer-to-peer device specific, but also when I was talking about applications, we really want to be able to interact between these microgrids with applications that can drive optimization, whether they be located at the edge and be optimizing for that interconnection point, or whether they're optimizing further up in the laminar framework. So I believe totally that this is where we're headed, and I don't think it's just going to be data centers. If you look at wildfire resiliency challenges, and you look at just community resiliency challenges, creating microgrids within the grid over time is going to become more standard, I believe, and utilities will probably be forced to do resiliency stations that will segment feeders into a supply and demand type of a scenario. And of course, across that, when we were talking model to model transformations, I think that's a big part of this, to be able to make sure that those standards are interoperable, so that regardless of how it gets implemented at the site, we'll be able to translate that and provide the peer-to-peer interaction necessary to optimize across multiple players and up various levels of the laminar framework.
Thanks, Kurt. Did anybody else have any thoughts? We have some more questions too that we can get to as well. So thank you guys for posting those. If you're in the Q&A, sometimes it doesn't automatically refresh. It'll say like new post, so you can click that button. So Scott Purser talked about the fact that he was building an AI application that generally involves importing sim models into Neo4j for GraphRAG applications. Would love to learn if OpenFMB could be used to ingest SCADA data into the graph database as well. We can definitely have an offline conversation about that. The short answer is I believe it can. And if you are, I'm assuming everyone here is a member, you can definitely be part of the conversation, and we can definitely have some conversations about how we might do that. So you can reach out. There's going to be an email address at the end of this. You can like reach out to us, Scott, and we can talk more about that if you would like to do that. So thank you. Paul Zawada said, what are the benefits of expressing the PIM in protobuf instead of something like JSON or XML? Jed, you want to take that?
to find the mute button here. Yeah, you hear me there now?
Yes.
Perfect. Okay. Yeah. So protobuf is a pretty rich and very strict representation. So we kind of think that we're going to have a JSON or YAML, and we'll still probably keep the XML exports in place, but those are very, very generic descriptors. So, and this might turn around. So we might actually, you'll see the JSON YAML kind of as the bottom human readable platform independent model. We might do a back and forth on those two things and come up with a strict syntax for the two. Protobuf is effectively a description language. It's already a rich schema syntax over top of those basic descriptive languages. And it is an intermediary. And again, it's kind of the derived intermediate that if you were going to make a change because you needed to add some stuff and get something working and prove that things are working, you're going to be working with the protobuf to get it generating into your language model so you can actually run the tests. And so then that becomes something that becomes pretty easy to contribute back rather than doing kind of a translation back from that protobuf back to a conceptual level. You can just add the extra information, things like descriptions, into that protobuf and then derive something that's maybe a little more human readable from that more specific opinionated language. So we've been playing with both. We've got some kind of experiments where we might do one, might do the other. So if you have opinions about that, Paul, or have people that have been playing in that space and think it should go one way or the other, join us. We're quite open to exploring different ways. This is not, the right-hand side is not set in stone. What we really want to communicate is we need something that's contributor friendly and allows for bi-directional kind of workflows, not just completely top down, but also bottom up of I added a point into the system. That means I facilitate this new use case, describe the use case and the specifics of the semantics required in the object model to be able to do that in a pull request, bring it back, and then everything else just gets updated. So that kind of contributor model is what we're going for. The specifics of it will be driven by the people that participate. So join us.
Let me just add more color. This could be a double arrow. It could be bi-directional between JSON and protobuf. Secondly, when we're talking about east-west communications on a wide area network like cellular, where data is costly, serializing the data as a binary in protobuf is going to be a lot more compressed than a text file like JSON or XML. So typically when you implement these peer-to-peer communications, protobuf is a lot more lighter weight and easier to move data. So that's another benefit, just to answer your question.
Thanks, Stuart. So thank you guys for the questions. Keep them coming. Robert, we'll take a couple more, and obviously keep asking the questions. We can answer them offline as well. Stuart, real quick, since you are unmuted, Robert asked both SIM and 61850, have you found overlaps? How do you choose which to use?
Yeah, so the original OpenFMB back in 2016, we used exclusively SIM. And we found SIM, though it is, standardized in the back office, has a lot of great attributes. It did lack a lot of the richness of the 6150 logical nodes, and we get into some of the parameters and enumerations. And so it was the decision of the community to kind of take the best and cherry pick the best of both worlds. And we've kind of taken the strengths of each. I think as we've learned with interoperability, as long as you have a consistent data model, it really doesn't matter what definition you use, as long as you're consistent. So ultimately, where there's overlaps, we just have to know, what those are and make sure you know how to map to that specific either SIM or 650 structure. But for the most part, we leverage a lot of the class structures and taxonomy of SIM, and then we leverage a lot of the, logical nodes of 6150 from a device level. But in general, as long as it's interoperable, it shouldn't really matter which, once you're in the OpenFMB model and you know how to map to it, that's really the goal.
Thanks. So Paul, you asked the question with the number of protocols being used by TSO and DSOs, is there a framework for OpenFMB users to add their own protocol adapters and possible extend OpenFMB models to incorporate TSO, DSO specific signals? Great question. That actually probably has, again, a bit more kind of nuance and a bit more detail that's required. The short answer is there is some possibilities there, obviously, to extend the models, both from a standpoint of things that you're trying to do, but also from a standpoint of the standards itself and working within. And this may be something that we want to explore from a 2.3 perspective. I'd encourage you again, as we kind of get to kind of the next steps, if you do have some use cases and some specifics or whatever, you can, bring it to the table. You could also participate and we can work on doing that and expanding the model as an organization. So I would sort of leave it at that, but if you want to explore that more, obviously reach out to us. Offline, and we'll see if we can't get talk to you a little bit more about it and integrate it and stuff like that. And then finally, Patrick Moran asked the question, are you guys watching Elf Energy in the EU and some of their working on message bus? This is probably a larger conversation. I think a lot of us are watching LF Energy. I don't know if anybody here wants to spend 60 seconds is probably what we have to talk about it.
I'll make a comment, Mike. So
yeah,
we have started.
It's a large topic. So yeah.
So the beauty of OpenFMB is driven off open source technology. The LF Energy is a community, and Linux Foundation in general is a really a good avenue for collaboration. In fact, could be a great partnership between UCA. We have reached out to LF Energy. I think at this point, a lot of what we've noticed is in the US around the grid edge Interoperability Security Alliance, which is going on around AMI 2.0. But I do know that they are looking at extending that GISA initiative in the US to support grid automation and DERs. So, but we're happy to ask them about the EU piece. But that's the first time I've heard of it. Thanks for sharing.
Okay. I want to thank everybody for their questions. This was really good. Hopefully you guys found this meeting to be very informative and encouraging. In terms of next steps, a couple of things we wanted you to be mindful of. There will be a survey coming out. It's going out to the entire membership list of UCA. We definitely would like everybody here who was part of this session to fill out that survey. There's things about the webinar itself, but then also in terms of OpenFMB, in terms of its applicability today and what you could potentially see as opportunities for tomorrow. So we want you to make sure you're looking out for that survey that will come out. It will come to your email, and we would like you to, respond to that. We also, if you found this very encouraging and somewhat educational, we want to make sure that you encourage others possibly to listen to the webinar and complete the surveys. Regardless of whether they've listened to the webinar, there's opportunities to provide feedback to us that we will take into kind of future endeavors and stuff like that. Going forward, there's a couple of things in terms of immediate time frame. Next meeting will probably be in the Q2 time frame, so we'll be looking at May or June. We'll be looking to. There's been a number of movement within the industry with respect to use of OpenFMB, and we're going to try and see if we can't get one or two people to speak to some of the things they're doing with OpenFMB and what they see in terms of applicability for OpenFMB within their own kind of use cases and stuff like that. So please look for a meeting invite and please plan to attend. And then finally, in terms of larger priorities for 2026, we'll be working on 2.3, trying to determine the scope and start to begin the data model work on that. And if you find interest, there was a couple of people who had some ways to perhaps extend the model. We'd invite you to participate in that. But there's also what we'll be trying to do is trying to get this message out to a broader group of people within the industry, so we'll be working on the marketing as well. With that, we're right at the top of the hour. I appreciate everybody's time and effort and listening today. Ryan, is there anything last that you want to say, or do we just cut it off from here?
No, I think that was great, everybody. Thank you for your time, and we appreciate you attending today and listening to the OpenFMB webinar. If you have any questions, there's plenty of ways to contact us now on the UCA and OpenFMB websites. And Michael and Stuart, thank you both, and Jed and Alex and everyone else involved. Thank you.
Thank you, everyone. Have a great rest of the day.